All right, so here's our problem set. It says draw a tape diagram to model each comparison. Use greater than, less than, or equal to compare. All right, I'm going to allow you to use any method that you want to use, including reasoning here. Okay, so we're going to get started on the first ones here. And I really want to just talk to you about how to reason about these fractions. It's super important that we understand how to do this. All right, so first of all, you see these are mixed numbers, so you compare the whole numbers first. You always go with the largest number. 3 and 3 are equal. Then I move on to the fraction, the piece that's less than 1. I have 2/3 and 5/6. Right off the bat, I noticed that thirds and 6 are related, right? Because I double the 3, I'm going to get 6, right? So I can make these into common denominators, all right? The same. Common means the same, right? So what I can do is just change this one into a 4/6, right? By multiplying the numerator and denominator by 2. So now I'm comparing this 4/6 and 5/6. And when I have common denominator, same size piece, I know that I'm just comparing the numerators now. 5 is greater. So this comes out to be 3 and 2/3 is less than 5, or 3 and 5/6, okay? Same thing with over here. Let's take a look. I compare the whole numbers first. 3 and 3, they're the same. So then I move on to the fractions. And I notice again, 2/5 and 6/10. These are different denominators, but 5 and 10 are related. A simple multiplication problem, if I multiply by 2, is going to give me a common denominator. So I multiply both the numerator and denominator by 2, and I'm going to get 4/10. Now I can compare this fraction to that fraction because my denominators are the same. So 4/10 is less than 6/10. See how I got that? Good. All right, moving on down. Letter C. All right, first step, compare the whole numbers. Okay, 4 and 4 are the same. So now I need to compare the fractions. 3/6 and 1/3. All right, 6 and thirds are related because all I have to do is double this 3 and I'm going to get 6. So I multiply both the numerator and denominator to get an equivalent fraction by 2. I'll get 2/6. And now I can easily compare those two fractions. 4 and 3/6 is greater than 4 and 2/6, okay? So I'll put that greater than sign in, okay? And then finally is this last one. I look at 4 and 5/8 and 19/4, okay? I'm going to need to take care of this somehow. I need to make it, I'm going to make this one into a mixed number and see what I can go from there, right? So 4 goes into 19 4 times, because 4 times 4 is 16. There'd be 3 left over to get to 19, right? So it looks like I've got 4 and 3/4. Okay, so now these are a little bit easier to compare. I compare my 4 and my 4 and they're the same. So I move on to my fractions. I see 8ths and 4ths. I know I can change this into 8ths by multiplying it by 2 because 8 and 4 are related. So I'm going to do that. I'm going to say 2 times 3 is 6 and 2 times 4 is 8. So I just turned 3/4 into 6/8, which are the same exact fraction. Now I can compare this 6/8 and this 5/8 and notice that 8ths and 8ths are the same, so that 6 is higher. So 4 and 5/8 is less than 19/4. Okay? I think doing it this way as opposed to making an area model or a tape diagram, tape diagrams can get very tedious, especially if you're not really accurate. Okay, so now down here it says use an area model. Again, we're not going to do that. What we're going to do is use the knowledge we know about fractions, benchmarks, and cross multiplication. Okay, so let's take a look at A. So right here, I notice off the bat that my denominators are not related, okay? There's no way I can multiply 5 by 2 and get 7, right? And over in this one, the same thing, 8 and 3 are 8ths and thirds are not related fractions. So I'm probably gonna have to do a little bit more work here. Okay, so first of all, let's change this 18/7 into a mixed number because I can tell that's a fraction greater than 1. 7 goes into 18 2 full times, because 2 times 7 is 14. 7th is going to remain my denominator, and there's 4 left over. So now I've got 2 and 3/5 and 2 and 4/7. So 2 and 2 are the same, so those kind of cancel each other out. Now what I'm comparing is 3/5 and 4/7. I got to figure out basically which fraction, not 2/5, it's 3/5, sorry. I got to figure out what fraction is greater, and I think this is a perfect opportunity for us to use cross multiplication, okay? So that's what I'm going to do. 5 times 4 is 20, and 7 times 3 is 21. Wow, really, really close. So I know 3/5 is just a touch higher than 4/7. So I slide back up here and look at my problem. I know that this fraction is just a tad bit higher than this fraction. So 2 and 3/5 is greater than 18/7. Pretty cool, right? Okay, move on to the next one. Yeah, so probably going to use cross multiplication for this one again, all right? What I like about this one is I don't have to convert it to a mixed number. They're both in mixed number form. So I compare the whole numbers first. 2 and 2 are equal. Great. So now what I need to do is compare the fractions. I got 3/8 and I've got 1/3. All right? I need to compare which one is bigger between those fractions, okay? So using my cross multiplication, 8 times 1 is 8. 3 times 3 is 9. Those are super close, but I know 9 is just a touch higher than 8. So I can tell that this side of the equation is a little higher. So 2 and 3/8 is greater than 2 and 1/3. Great. We're cruising right along here. Okay, now on the back. Now this is the point here where you're going to practice on your own, okay? So teachers will pause this video and then kind of play it to see the fractions, okay? And how they're played out. So when you replay this video, when you start it up again, all the answers will be there for you, okay? And then the teachers can kind of check in with the students as they're doing their independent work, okay? All right, so teachers, pause now. All right, hopefully that was okay for you. So here we go. We're gonna go over the answers to the back of the problem set and go from there. So A and B, I got greater than and less than right here, okay? You can see where I did my work underneath. I kind of changed the fraction, so I got common denominators, and it was pretty easy to tell. Okay, C and D. All right, same thing. I got greater than here, and I got less than here. And you can tell what I did. I got common denominators to figure out, which fraction was greater. See, 15ths and 15ths. I can tell when those denominators are related because I know my multiplication facts really well. All right, down here, good. This is when I started reasoning with half, okay? I don't know about you, but this is what I did. And whole numbers, all right? So I found 3.5, and I look at 7 and 7. I know halves are bigger pieces, so I know that's bigger. Over here, I just converted it 4, and this was just a touch lower than 4. And then down here, okay? What I started doing is, comparing these fractions here with, understanding the value between the same numerator. See, it's both 2, and I know 5ths are bigger than 7, so this is greater. And then over here, I had to do cross multiplication. I don't know about you, but I changed this to a mixed number, and then what I did was compare the 1/4 and 2/5. Cross multiplied, and this came out higher, so that's there, okay? So that would be a less than symbol, and then let me just take this out of there. Okay, down here I had to do a lot of work. I had to first change all of those fractions both those fractions to mixed numbers. And then I got 8ths and 3rds, which aren't related. So then I just compared the fractions, right, like this, and I got cross multiplied and got 15 and 16 and 16s, just a tad higher. I got less than. And then finally, over here, I did the same thing. This one was great because it was already put in mixed number form. So 3 and 3 are the same. Cross multiplied to figure out these because 4ths and 7ths are not related. And 21 on this side came out just greater, okay? All right, hopefully that was successful for you. Tomorrow we'll be doing line plots, and that should be a lot of fun too. All right, kids, have a great day.